What is Le Chatelier's principle? But first of all, how do you say it? It is not Le Chatelier, Le Chatelet, or Chatelier, or anything else, whatever you plan to say that is not Le Chatelier. Hey, that rhymed. Whatever. Now seriously, Le Chatelier's principle. What is Le Chatelier's principle? Le Chatelier's principle states that if a dynamic equilibrium is disturbed by changing the conditions, the position of equilibrium, that is, the state where the forward and backward rates of reaction are equal, equilibrium. Let's write it down here just in case. Equilibrium. If it is disturbed, according to Le Chatelier's principle, then the position of equilibrium will shift to counteract the change and re-establish the equilibrium that was lost. The conditions that affect equilibrium, according to the Le Chatelier's principle, are pressure, temperature. I'm sorry, the tablet is a bit glitchy today. Temperature and concentration. Concentration of the reactants and or products, by the way. Now let's give an example. Let's say we have a reaction, molecule A plus molecule B, which is in dynamic equilibrium with molecule C and molecules D. Now we mentioned dynamic equilibrium, which is symbolized by these arrows here, or you could also write it like this, doesn't matter. Dynamic equilibrium means that the forward reaction rates, the forward rate is equal to the rate of the backwards reaction, the reverse reaction rate. Now the forward reaction rate is when A and B are the products, are the reactants, and C and D are the products. And the reverse is when C and D are the reactants and A and B are the products. Dynamic equilibrium is when those two reactions happen at the equal rates. But that does not mean that the concentrations of the products and the reactants are the same. It does not mean that. It means that the concentrations are no longer changing because the reaction rates are the same. Now, the principle of Le Chatelier's principle states that if you disturb that equilibrium, if you disturb it, well, we have three factors that will disturb that equilibrium. Let's change the concentration of one of the reactants, molecule A. Let's add more molecules of A. Now that there's a higher concentration of A, the likeliness of molecules A colliding with B, reacting with B, is higher than the reverse reaction's likeliness of C and D colliding, which makes the forward reaction rate, all of a sudden, it is greater than the reverse reaction rate. They're no longer equal, so they're no longer at equilibrium. But because of Le Chatelier's principle, we know that it will correct itself. Because more of the forward reaction rate happens, it's greater than the backward reaction rate, then there will be more of C and D. So C and D are going to rise too because the forward reaction rate is happening more than the reverse reaction rate. Therefore, C and D will be made in greater amounts than A and B will be made. So then, because the concentrations of C and D are greater because the forward reaction is greater, then suddenly C and D has a higher reaction rate because it is more likely. So it keeps going back and forth because there's more concentration of C and D now. It's more likely than the forward reaction rate. And it's going to keep going back and forth until a new equilibrium is reached where the concentrations are now at equilibrium. Because we added more on this side, remember we added on A, naturally the reaction is going to balance itself out. We added stress on this side, so the reaction will progress towards the reaction with less stress. There's more concentration with A and B, there's more stress. It is going to proceed towards reaction C and D, where there is less stress. Now, that's the basic idea of Le Chatelier's principle. It is just going to balance itself out. It's going to relieve stress. Now, that's if we add concentration. What if we added heat to the reaction? So instead of A plus B is in dynamic equilibrium with C plus D, we're going to add some heat into the equation. So it's going to be A plus B plus heat. There is now heat in this equation, which is in equilibrium supposedly with C plus D, but since there is heat, it is not in equilibrium. Now, because we added heat in this side of the equation, the forward reaction is going, the reaction is going to progress in the forward direction. It's going to progress towards C and D because we added more heat. The more heat, the more likely the reaction will progress in the direction with less heat. So basically, we are adding more stress again to this side of the equation, A plus B plus heat. I'm sorry, I had to rewrite it because there was a bit spacey on the other side. So A plus B plus heat, C plus D. So because of the heat over here, there is more stress. So the reaction will progress towards the side of the reaction with less stress. Basically, more heat on this side. So the reaction will progress to the direction where there is less heat. Same as through with the concentration. There was more concentration on this side, so it progressed towards the direction with less concentration. We're adding more stress by adding more heat. So to relieve that stress and balance out the equation, the reaction is just going to balance itself out. We've gone over this before. Now, what if we did the opposite? What if instead of adding heat, we will remove heat? Remember, we added a while ago, so now we're going to take away heat. So the reaction is going to favor the side with less heat, less stress, because if you take away heat, you take away some of the stress, therefore one of the sides will have more stress. Like I mentioned a while ago, this side is now, this side now has more heat than the other side. So to relieve that stress, the reaction is going to balance itself out, and it's going to favor the side with less heat. Basically, this and all in all, if you add stress to the one side of the reaction, if you add stress to one side, it is going to progress in the opposite direction to balance it out. So if you add stress in the products, it's going to balance it out to the reactants. If you add to the reactants, it's going to balance itself out to the products, and vice versa. Let's cover what basically Le Chatelier's principle is. It is a reaction in dynamic equilibrium in which that equilibrium is disturbed by changing either pressure, temperature, or concentration.